Students, good morning. Today I am going to discuss about the constant temperature process. Isothermal or constant temperature process. Constant temperature process. Isothermal or constant temperature process means the temperature of the system remains constant during its operation. Temperature of the process remains constant. Temperature is constant. Hence, the changes in temperature dt is equal to 0. dt is equal to 0. Temperature is constant, hence changes in temperature is equal to 0. Here we have two modes. One is expansion, another one is compression. One is expansion process, another one is compression process. Expansion and compression process. Expansion under constant temperature condition is called it as isothermal expansion. Isothermal expansion process. Isothermal expansion process. Compression under constant temperature condition, this is called as isothermal compression. Isothermal compression process. In isothermal expansion process, we are supposed to supply certain amount of heat added to the system. We are supposed to supply certain amount of heat to the system for expansion process. We have to add certain amount of heat for expansion. Upon addition of heat, there is no temperature of the system. The heat is completely replaced for expansion process. During compression, isothermal compression, we must release certain amount of heat from the system in order to maintain the temperature. Clear? If you are going for compression, the molecules will come closer to each other, hence it definitely release certain amount of heat. The same amount of heat should be released in order to maintain the system temperature. This is isothermal expansion, this is the isothermal compression process. At any cost, the internal energy of the system will not be disturbed because internal energy is a function of temperature alone. Now I am going to discuss work done, heat interaction, changes in internal energy, changes in enthalpy for isothermal constant temperature process. Isothermal or constant temperature process. First one is work done. Work done. Another one is Q, heat interaction. Heat interaction. Changes in internal energy. Third one is changes in internal energy. Fourth one is changes in enthalpy. Changes in enthalpy. Here, right. These four information can be get clarified by using first law of thermodynamics. First law of thermodynamics. Right. What is the first law of thermodynamics? du is equal to dq minus dw. Since temperature is constant, there is no changes in internal energy. Hence, system gets cancelled. So, changes in internal energy. Changes in internal energy is equal to 0 for an ideal gas. Changes in internal energy is 0 for an ideal gas under constant temperature process or isothermal process. Since it is 0, dq is equal to dw. dq is equal to dw. We well known that Q is equal to W is equal to P integral dV. Limit V1 to V2. For an ideal gas, PV is equal to N into R into T. For 1 mole of an ideal gas, this equation becomes PV is equal to R into T and P is equal to 1 by V into R into T. Now I am going to substitute this equation here instead of P. So Q is equal to W is equal to R T integral 1 by V into dV limit V1 to V2. This equation becomes R T ln V2 by V1. This is the heat interaction between heat and work in a constant temperature process. This is equal to N R T ln V2 by V1. N R T ln V2 by V1. For an ideal gas, P1 V1 by T1 is equal to P2 V2 by T2. Since the temperature is constant, T1 and T2 are equal. This equation becomes P1 by P2 is equal to V2 by V1. Now I am going to substitute this here. The final equation is equal to RT ln P1 by P2. Clear? Heat and work interaction based on pressure. Heat and work interaction based on volume. Clear? Enthalpy, internal energy change is equal to 0. Heat work interaction is established. What about the changes in enthalpy? Enthalpy H is equal to U plus PV. dH or del H is equal to du plus del PV or dPV. Listen, changes in internal energy is equal to 0. The amount of heat added to the system is completely utilized for work done. Either work done on the system or work done by the system. Work done on the system means it is a compression process. During compression, enormous quantity of heat will be released. The same amount of heat will be removed from the system. There is no changes in temperature. Similarly, in expansion process, we are in need of certain amount of energy for expansion. The same amount, the amount of heat added for expansion process is completely utilized for work done by the system. Hence, changes in enthalpy is equal to 0. Del H is equal to 0 for an constant temperature or isothermal process of an ideal gas. Okay? Thank you.